Example 15.9 says consider Kc for the following equilibrium. What that just means is what is the Kc value? And they give us the initial the initial moles of SO3, our reactant, in 1 liters. Usually they give you a different liter because they want you to calculate the concentrations of everything for initials, but luckily they gave us 1 liter. So 0.15 divided by 1 is just 0.15, so we don't actually have to do any further math. And then it's allowed to come to equilibrium, and at equilibrium the concentration of SO3 is 0.0076. Okay. We're going to have to do an ice chart because we have initial concentrations, and in order to find the equilibrium constant, we need equilibrium concentrations. Okay, let's set up our ice chart. We have our initial concentration, our change, and our equilibrium. Our initial concentration of SO3 was 0.15. Our initial concentration of SO2 is 0 and O2 is 0. Because before a reaction even starts, we only have reactants and we don't have any products yet. The change represents the amount that is changing to reach equilibrium. So reactants will decrease and products will increase. So that's why I'm going to put a negative in front of the change on the reactant side and a positive on the product side. We usually put an X, but we also have to remember that the number out front has to follow it down. Oh, circled the wrong thing. So I'm going to have to put a 2x here, and this one would just be a 1x. So I'll just leave it as regular x. So at equilibrium, SO3 is 0.15 minus 2x. But it told us that at equilibrium the concentration was 0.0076. So that means that at equilibrium, 0.15 minus 2x is equal to 0.0076. For SO2 at equilibrium, it's just 2x, and O2 is just going to be x. Why is this important? Well, if we write our K expression, let me do a different color. Then we get our products divided by our reactants. And whatever is in our equilibrium, those values are what we're plugging in. But since we don't know what x is, we need to calculate x before we can do so. But that's where I'm getting these values. So I'm just going to rewrite my equilibrium concentration, or sorry, constant, SO2 Okay, and we know that for SO3, 0.15 minus 2x is equal to 0.0076. So I'm going to subtract 0.15 on both sides, and I get minus 2x is equal to negative 0.1424. So I'm then going to divide by negative 2 on both sides, and x is equal to 0.0712. Okay, now we can figure out what our K value is so we can plug in x for everything. So going back to our ice chart, we know that the concentration of SO3 at equilibrium is 0.0076. The concentration of SO2 was 2x, and the concentration of O2 was just x. So we can plug everything in doing that. So K is equal to 2x, which was 2 times 0.0712 squared times x divided by 0.0076 squared. Now, if you want to plug this all into your calculator at once, just make sure you have the parentheses correct. You don't put the 2 behind this number because then you're not squaring that 2. And you need to square both the 2 and the value of x. So just put a parentheses around here and then square it. And then you make sure you put another parentheses around the top value. So when I plug everything in, I get k is equal to 25. I rounded up. It was 24.99, which is just 25.